And it should be recording and you guys can hear me, so we'll get going. Sorry. Sounded like you guys were talking about that partial fraction decomposition one.
Yeah.
Yeah, that's what it sounds like. All right. We'll get to that one. Don't worry, we'll do that if you guys want me to. Or I think it's in the problems we're going to do right now. So we've got a cylindrical barrel filled with rainwater, or it's collecting rainwater, and we know that the rate of change of the height is dh dt, which is negative 1/10 root h. And h is measured in feet and t is measured in seconds, and we know the volume of a cylinder. So we want to find the rate of change of the volume of the water. So we're looking for what is dv dt. And dv dt we should be able to get from the volume formula, pi r squared h. Remember, when you're doing related rate questions, don't ever plug anything in unless it's not changing. So we can do that actually with our radius, because our radius is 1, it being a cylinder. Radius doesn't change, so this just becomes volume equals pi h, or dv dt equals pi dh dt. And since we're given since we're given dh dt, this just becomes negative pi over 10 root h. And we want to know what it is when h is 4. So that should be negative 2 pi over 5 feet cubed per second. Any issues on that?
I thought when
can you explain again why you just cancel out the radius?
Well, the radius is 1 for the entire cylinder, right? It doesn't change.
Oh yeah. Mm-hmm.
So our volume just becomes pi times h. And so we just take the derivative of dv dt equals pi dh dt.
So if h is 4, wouldn't it be 2 over 10, which is 1 over 5?
We got pi dh dt, right?
Yeah.
And that's negative pi, or that's pi times negative 1/10 root h.
Right. And then root h is equal to 2.
Yeah. Oops, sorry. Yeah. Arithmetic's hard. Sorry, yeah. Negative pi over 5. Root h is 2. Root 4 is 2, not 4. Thanks. Good or no?
Could you redo that step again? Because I got, when you differentiate pi r squared h, do you get 2 pi r
No.
dh dt?
No. R is 1.
R is 1.
Anything that is unchanging, like the radius of a circle, the radius of this cylinder does not change. R is 1, plug it in, and then you get pi h.
Okay, all right.
If you do it the other way, I assume you had pi r squared dh dt plus 2 pi r h dr dt?
Yes.
Yeah, so I mean, I don't know what you put in for your dr dt, but you should have put in 0 for your dr dt if you had a dr dt there, because the radius isn't changing. So if you do it that way, that's fine. But then that whole second part of it cancels out, and you're just left with the pi squared h dh dt, and the r is 1, so that cancels out anyway. It still just becomes pi dh dt. Does that make sense?
Yeah.
Okay. Any other questions on that? All right. When the height of the water is 3 feet, we want to know if the rate of change of the height of the water with respect to time is increasing or decreasing. So the rate of change of the height is dh dt. And we want to know, is dh dt increasing or decreasing? Which means we need to figure out what's the derivative of this. If the derivative of this is positive, then it's increasing. And if the derivative of that is negative, we need to now tell us that it's decreasing. So You've got to find the second derivative with respect to t. The derivative of negative 1/10 root h with respect to t, well, that's still just a negative 1/10. The derivative of root h is 1 over 2 root h. And since we're taking the derivative of h with respect to t, that adds in another dh dt attached to the end of it. So now what we've got is negative 1 over 20 root h times negative 1 over 10 times root h. The root h's cancel and you get 1 over 200. And at any value that you evaluate 1 over 200 at, for any h value, 3 or any other value, that's still greater than 0, which tells us that it's increasing. Any questions on that one?
Can you explain again why it's the second derivative?
Okay, we want to know whether the rate of change of the height is increasing or decreasing. So we want to know, I mean, you figure out if something's increasing or decreasing with its derivative, right?
Oh,
Right.
I see, okay. Yeah, no, that makes sense
The
now.
rate of change of the height is already dh dt, so its derivative is the second derivative of h with respect to t. Good?
Yeah. Thank you.
Other questions on part B there? Okay. Part C, we want to use at t equals 0, the height is 5, and use separation of variables to find an expression for h. So dh dt, we still have negative 1 over 10 times root h. When we separate the variables, this gives us dh over root h equals negative 1/10 dt. Integrate both sides, and you've got 2 root h on the left, and you've got negative 1/10 t plus a constant on the right. Plug in your initial condition that when t is 0, h is 5, and that gives you 2 root 5 as your constant. So then you've got 2 root h equals negative 1/10 t plus 2 root 5. Divide by 2 and square it. H equals negative 1 over 20t plus root 5 squared. Any questions on that one? You guys can still hear me all right?
Yep.
All right. Everyone's good there? No questions coming up in the chat? No? No? All right. Sounds good. Let's move on to the next one then. So this is the next one they recommend you guys take a look at. This is number 5 from the 2019 test. And they're giving you 1 over x squared minus 2x plus k, where k is a constant. We want to find the value of k for k greater than 0. So the slope of the tangent line at x equals 0 is 6. So slope of the tangent line means take the derivative of 1 over a function. You can use the quotient rule, or we can use the reciprocal rule. Reciprocal rule says that f prime is equal to negative denominator's derivative, so negative 2 over the denominator squared. And we want, at x equals 0, we want this to equal 6. So if x is 0, that gives us 0 minus 2 is negative 2. The opposite of negative 2 is 2. And then we got 2 over k squared, because x squared minus 2x at 0 is just 0, equals 6. Or, cross multiply, you got k squared equals a third, or k equals root 1/3, or 1 over root 3, or root 3 over 3, or however you want to write it, doesn't matter. Any questions on part A there? Okay. Then it says for k equals -8, find the value of the integral from 0 to 1 of f. So we're looking for the integral from 0 to 1 of 1 over x squared minus 2x minus 8 dx. This is not one we can real easily do unless we factor it. So we'll take this as an integral from 0 to 1 of 1 over x minus 4 times x plus 2 dx. And we'll use partial fraction decomposition to separate that out. So this should become, we'll say that a over x minus 4 plus b over x plus 2 is equal to 1 over x minus 4 times x plus 2. And then when we get a common denominator here, we get ax plus 2a plus bx minus 4b equals 1, which tells us that a plus b equals 0, and that 2a minus 4b equals 1. And if a is negative b, we can plug in negative b down here. So this gives us negative 6b equals 1, or b equals negative 1/6, which tells us that a equals positive 1/6. So far, everybody good? No questions there? Okay. So we'll now write this as an integral from 0 to 1 of a was 1/6, so 1 over 6 times x minus 4, and then minus 1 over 6 times x plus 2 dx. There's no discontinuities. There's one at 4 and -2, but none on our interval, so it's not an improper integral. So we'll just integrate. This becomes 1/6 natural log absolute value x minus 4 minus 1/6 natural log absolute value x plus 2 from 0 to 1. And let's see, if we plug in 1 there, we got 1/6 of the natural log of 1 minus 4, which is -3. Absolute value is 3. So 1/6 ln 3 minus 1/6 again, ln 3, so that part's going to go away, minus 1/6 ln of 4, and then minus 1/6 ln of 2. And since they don't require you to simplify numeric answers, you can leave it like that if you want, or you can, I would, if it were me, I would at least write it as 1/6 ln 2 minus 1. If you really want to simplify it, or if there was a need to simplify it further, this is 1/6 natural log of 2 over 4, or 1/6 natural log of a half. You could write it as negative 1/6 ln 2. Any of those would be fine. Any questions on that? You guys can all still hear me, yeah?
Yeah.
All right. Everyone's good? All right. Let's go on to the next part of it then. For k equals 1, we want to find the value of the integral from 0 to 2 of f of x, or we want to show that it diverges. So what did we originally have? X squared minus 2x minus k, is that right? Or plus k? So we're looking at the integral from 0 to 2 of x, 1 over x squared minus 2x plus 1. or probably prefer to write that as integral 0 to 2 of 1 over x minus 1 squared dx. And then we'll note that there's a discontinuity at 1, which happens in the middle of our interval from 0 to 2, which means that we've got to split this up into an integral from 0 to 1 of 1 over x minus 1 squared dx, plus an integral from 1 to 2 of 1 over x minus 1 squared dx. And then both of those are improper integrals, so we have to write those out as the limit as a approaches 1 from the left of the integral from 0 to a of 1 over x minus 1 squared dx, plus the limit as b approaches 1 from the right of the integral from b to 2 of 1 over x minus 1 squared dx. Everybody good so far? Point to
so
note.
You can't integrate at a discontinuity.
That's correct. That's what an improper integral is.
Okay.
So the most important point here is if that discontinuity falls in between here or at one of your endpoints, you have to write it out in the limit notation. If you don't write it out in the limit notation, you're not doing the improper integral correctly, and they're not going to give you the points for it.
You also have to write limits for like infinity, right? Those are also.
That's correct.
Okay.
Yep. For any improper integrals. And that sheet that I sent out to you guys with all the, that is like 8 or 9, 10 pages long or something of all that stuff I typed up, that stuff, all of the different forms for the improper integrals are in there. So take a look at them, review them, make sure you know them. And then if you blank out for a second on the test, then grab that sheet and look at it, but have it next to you. And I'm going to suggest you really look through that sheet tonight if you haven't already, and just make sure you know what's in there. So if you're forgetting something or you just want to check and make sure you're right, you know where it is. Hopefully that sheet will be.
If there was more than one discontinuity between 0 to 2, like if it were like x minus 1, and then, or if it were like 0 to 3, and then there was a discontinuity at 1 and 2, would you have to split it up into like 4 different integrals?
You just have to, yeah, as many as you needed to, you'd have to keep splitting it up. Any discontinuities have to be split into limits.
All right.
Yep. All right, so now we can start to evaluate this. Limit as a approaches 1 from the left of the integral of x minus 1 squared. That's x minus 1 to the negative 2, or u to the negative 2, which should be negative 1 over u. The u substitution, the du dx is the same. So it's just negative 1 over x minus 1 from 0 to a, plus the limit as b approaches 1 from the right of, same thing here, negative 1 over x minus 1 from b to 2. And as you go in here, you've got the limit as a approaches 1 from the left of negative 1 over a minus 1 minus negative 1 over 0 minus 1. I don't know what happened here. That should have been minus negative. There we go. Plus the limit as b approaches 1 from the right of negative 1 over 2 minus 1 minus negative 1 over b minus 1. And as you come through to try and evaluate this, as you plug in 1 from the left here, this limit is undefined. There's another one over here that's also undefined. It doesn't really matter which one you state. But since this limit doesn't exist, then the improper integral diverges. We'll say this limit does not exist, so the entire thing diverges. And you'd want to state why you're saying it diverges. Don't just write this and then say, it diverges, because then they're going to say, well, you don't know how to evaluate that. You just took a guess. So
the reason would be Like you would say it doesn't exist. Like that's all you have to write it, or
Yep. If you just, I mean, you could just write that the limit of as a approaches 1 from the left of -1 over a minus 1 doesn't exist, or you could have said the same thing for the one of -1 over b minus 1. That one doesn't exist,
Okay.
and therefore it diverges.
Wait.
And is that the one you guys were talking about? Well, I got
Yeah.
kicked out of the meeting. Yeah. Okay.
Yes.
So I thought.
Wait, didn't
Everybody
we do
good
like
there?
for limits, like when like we plug in a value really close to 1 from the left side into A, and then like solve it like an estimate sort of thing?
I mean, it's going towards infinity, but they're both going either towards infinity or negative infinity, but and a limit that goes towards infinity or negative infinity still doesn't exist. And so, I mean, there's no numeric number that you can put in there.
Oh, I see. Because it's approaching infinity, and that's why it doesn't exist. Okay.
Correct. A limit, for a limit to technically exist, it has to reach a finite number. We use infinity or negative infinity just as a tool to guide us and say, oh, this is sort of what this graph looks like. But technically, those limits don't exist.
All right, cool.
Wait, so you only have to do the limit notation thing for infinite discontinuities, right?
Yes, any infinite discontinuity or going towards infinity or negative infinity.
Okay.
Like I said, they're all on that sheet that I sent out. So take a look at them on there. Refresh your memory on them tonight.
Do you think
Any other questions on that one?
do you think there's a chance that they'll give you one where the discontinuity isn't like clearly obvious like in this one?
They're not going to try and trick you. I don't think like that. No. I mean, I think a lot of people would just overlook the fact that this one has a discontinuity there and just go through and do it. And because if you go through and try to evaluate it from 0 to 2, you get an answer. Right? I mean, you know, you just end up with -1 over x minus 1, and you end up with -1 over 2 minus 1 minus -1 over 0 minus 1, and you get something. I don't know. It comes out to be something.
It's 0. I did it.
It comes out to be 0. Yeah, it comes out to be 0. And so, I mean, you might think that you did a good job, but yeah, a lot of people, I would guess that 20 to 30% of people that took this exam would overlook the fact that there's a discontinuity in between there. So they're not going to try and trick you. But
for the problems that you've seen that include the indefinite, what is it called? This type of integral, do all of them have this kind of clause that says, or show that it diverges?
Yeah, I mean, that's a clue in there. If you see something that says, or show that it diverges, there's a possibility that it diverges, which means that that what you're looking at is probably going to be an improper integral. Yeah, I mean, it could possibly say that, and then it's not an improper integral. But if it says, or show that it diverges, chances are it's an improper integral, and you need to like be extra careful with it.
So whenever you take the integral, like before you take it, you need to check for these things, right?
Yes.
Okay.
Yeah, I mean, the only thing we did was we factored it first and said, oh, it's 1 over x minus 1 squared. And then we said, oh, shit. Oh, wait, sorry, I'm recording this. I can't do that. Oh, shoot. This has a discontinuity at x equals 1, right? And so at x equals 1, I have to break it up.
All right, thank you.
Yeah. If you go any further than right here without breaking it up, they're not going to give you points. So.
If A was infinity, and then it was like when you're evaluating the limit, it's like 1 over infinity, which is 0. Technically, that exists, right? Like even though it's 1 over infinity, you can say that that equals 0. Okay.
That's 0. 0 is a number. So yes. Right. Yep. Other questions on that? All right, let's move on to the next one. This one is a calculator question, but they said that the content from this one would probably be tested, but that they would rearrange it so that it didn't require the use of a calculator. So we'll just do it with a calculator because we've got a calculator in front of us. If you want to, I've got one by me because I'm prepared for class. So take a look at it, read it for a second, and then we'll get started on it. All right, so we want to know how many fish enter the lake from midnight to 5. We got a function that models the rate at which they enter the lake, so this should just be the integral from 0 to 5 of e of t. Anytime you have a rate function and you want to know how much of something, just integrate it. So for those of you that are wanting to know what the actual value there is, comes out to be $142.766, I believe. Is that what you guys got? Unless I typed it in wrong. 20 plus 12. I typed it in wrong. Shoot. I wrote 12 instead of 15. Comes out to be 153.458.
Yeah.
Does that sound better? Yeah. 458. It says round to the nearest whole number, so 153 fish. Any issues on that one? All right, we want the average number of fish that leave the lake over the 5-hour time period from midnight to 5. So this is the number of fish that leave is the integral of the leaving function. And so if we want to know the average of that, we use the mean value theorem for integrals, 1 over b minus a times the integral from a to b of the leaving function. So you got a calculator, you should be able to do that. You could do that without a calculator too. But any questions on the setup of that one? And that one comes out to be 6.059, I think, unless I typed that one in wrong also. Does that sound good to you guys?
Yep.
Perfect. Any questions on that?
I think it says like rounding, like they say to round to the nearest whole number. If you don't round, like, is that a point off?
Yep.
Okay.
Yep. If they ask you to round it. Yeah, always 3 decimals. Well, I mean, it doesn't matter because it's not a calculator thing now, but it would always be 3 decimals unless they specify otherwise. But yeah, they could still ask you to round some simple fraction or some simple decimal on this year's test. And if it says to round it, round it.
And also always include the units, correct?
Yeah, I mean, always include the units. There's not usually a point attached to them unless it says indicate units of measure, but just to be safe, put it on there.
Okay.
I could say the average number of fish is 6.059 fish per hour. Doesn't say it. They're not going to give you points for it, but it's good to be complete and correct. All right. At what time t for 0 to 8 is the greatest number of fish in the lake? So how many fish are in the lake? The integral of e minus the integral of L. That's how many are in the lake. And we would know that the number of fish in the lake, their derivative should be the rate functions. So we could say that the number of fish is the integral of E of t minus L of t. And so the derivative of that is from 0 to any time period during, so 0 to x dt. So the derivative of this needs to equal 0, which is just E of t minus L of t equals 0. And we will figure out when that's true from our calculator. Does that make sense to everybody?
Could you show like the functions if possible?
Yeah.
Thank you.
Wait, why do we take an integral in C? Why don't we just do E of t minus L of t?
Well, E of t minus L of t is the derivative of the number of fish. It's the rate at which the fish are entering, or the rate at which the number of fish in the lake are changing is E of t minus L of t. So we want to know when the greatest number is. We can see when that's equal to 0. But officially what we're doing, like technically what we're doing is we're saying that the number of fish in the lake is the integral from 0 to x of E of t minus L of t dt. The derivative of this is E of t minus L of t. We set that equal to 0.
So you have to write that to get full points.
No, I believe actually in the scoring guidelines it said you could have just set E of t minus L of t equal to 0, and that was acceptable.
Okay, cool.
And let's see, I'm graphing the two on my graphing calculator real quick to see where they intersect. Four plus 2 to the point 1 plus 15 sine pi x over 6. Okay. And what were we talking about? 0 to 5. No, 0 to 8, right?
Yes.
Nah, my graphing calculator is being slow. Did somebody get a value for that?
6.203.
That doesn't sound right.
I got 80.920, I think.
Are we talking about the value of t, or are we talking about?
No, the question specifically asks for at what time is the number of fish in the lake the greatest, and that for me came out to be t equals 6.204 hours.
Okay,
I got 6.05904.
You typed something in wrong. Or
Wait,
else
no, that was the wrong problem. Yeah, never mind.
Perfect.
Yeah, 6.204.
No, it'll be a simple algebraic equation on the test if they give you this type. So like, you know, don't necessarily need to worry too much about the calculator work at the moment.
And do we need to do a sign chart even though that's the only 0 on that interval?
You should. No, I mean, you could, but it's not going to be necessary on this one, I don't think.
Do you have to check endpoints?
Oh, we got a closed interval, yeah. So the greatest number. So you got to check the endpoints. That's true.
Okay.
Yeah, thank you for mentioning that. I didn't do that. T equals 6.204 is one option. T equals 0 is another option, and T equals 8 is another option. So yeah, you got to do the chart. Either a chart or a sign chart like this. And at T equals 0, let's see, E of t minus L of t should be positive. Yeah. So we're increasing, and then we are decreasing after that at t equals 8. So you show your sign chart. Good on that or no?
On other questions, when it says to explain, will a sign chart be enough to like explain, or should you also like add more?
As long as your sign chart is well labeled and clear, then that should be fine. But an extra sentence doesn't hurt.
All right. All right, thank you.
To check, because like you have to check which one is like actually the greatest number of fish, right? Like which times. So would you have to just use that integral expression, the first expression you wrote?
And say that again. You were breaking up.
So like to find, because you have 3 times, right? And you need to find like the absolute maximum. So would you have to use that integral expression to like plug it in and see which number of fish is the greatest?
You could, or you can just plug in E of t minus L of t as your derivative and say that the derivative was positive at t equals 0 and negative at t equals 8. And so therefore, we were increasing and then we were decreasing. But you could plug them in. Yeah, you could plug in the integral from 0 to 0 of E of t minus L of t, which is 0, and the integral from 0 to 8 of E of t minus L of t, and get a number for that also, and do the same with 6.2 and show that that one's the largest also. Either way.
All right.
Wait, so you did a sign chart for this?
I mean, I did. I didn't really write it all the way out, but yes.
Oh, okay, and then it was just 6.2.
0 was increasing, and at t equals 8, it was decreasing. So.
Oh, okay, gotcha.
6.204 was it the max.
Cool. All right, thanks.
Yep. All right, part D, is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.? So the rate of change, well, our rate of change is E of t minus L of t, and we want to know if that rate is increasing or decreasing. So we are looking at E prime minus L prime evaluated at t equals 5, and you've got a calculator that will do that for you once again. If this was the actual test, you'd have to do it yourself, but you don't. So plug it in and see what you get. I gotta go back to the equations for a second here. Any questions on the setup there, though? I think I got negative 10.7. Does that sound right to other people?
Yeah.
Which is less than 0. So it's decreasing. All right, those are the ones they recommended. Now they'd sent out a few other ones that I forwarded along to you guys, and they didn't put up any answers for them. They have videos up where they show the solutions to them already, I guess. So if you wanted to go check the videos on those, you can. But you can also just ask me now if you have any questions on any of those. Some of them we already did.
It looks like it's the same graph, but it's completely different questions than the ones we did.
Oh, is it?
Yeah. It's more, it look for like all of them.
Oh, really? Okay, because for A, B, a lot of them were exactly the same, or they only added in a couple of things. But
you're talking about the videos that are just on the College Board like YouTube channel?
Yeah. It's within. If you go into the BC one, they should have. I thought they had done these solutions to these. I could be wrong though.
I haven't really been checking those. So that's like where you'll get those answers to these.
Yeah.
Well, they should. I'm pretty sure they're up there. But if you have any questions on them, I'm happy to go through them right now. Or if you just kind of, I mean, I haven't watched those videos. They just said, oh, here's the videos about them. I was like, all right, cool. But let's see here. Man, this stuff is showing up weird on here when I tried to put it up here. Oh, I see why. All right. Okay, so if we're looking at that first one, it was just a single page. It says practice exam question number 2 with the chart.
Yeah.
Does anybody have any questions on that one?
Is it the one with velocity?
No. Here, I'll give me 1 second here. I'm just going to resend the link to all of you guys right now so you can just pull it up on your phone and look at it. All right. Should go through here hopefully in a second. Did you guys get the message with them, with the link?
Oh, this one. Okay.
So if you click on BC1, is everybody okay to see those? Everybody can see those?
Yeah.
Okay. So for that first one with the chart where it gives you, x is 1, 3, 8, and 9, and f of x has those values, and f prime has some other values. Anybody need help with part A? Just the quotient rule right there, right? You guys just want me to sort of kind of quickly go through these or no? Or would you guys prefer to just do them on your own and ask questions?
Yeah, I think that's better.
Okay.
I just used like an answer sheet so I could just check my work.
What's that?
I just wish there was like an answer sheet to check my work.
Yeah, I can try and get through and do them all. Let's I'll do my best to get them done tonight.
I did them all, so I could like give the answers because I checked with the solutions online too.
Oh yeah. Okay.
Yeah. Hold on.
Did you get them right, Fred?
Yeah, I checked with the solutions online.
You just send the link of the solutions?
There's no link. It's the video, and then they go through like everything on the video.
Yeah, that's what I thought. Yeah. Do you have the link to the video? I can send the video out to everybody, and then that's probably easier if you guys can just watch the video of it, and then if you still have questions, I'm happy to answer
I
them.
just searched up. I went to their YouTube page, and then they had like all the classes, and then if you go down to the very end of their playlist for Calc BC, it has like all 3 of the exams.
Okay, that's what I thought. That's what I was saying earlier. So let me.
And then like I think they review the answers for the previous exam on the next exam. So if it was like exam 1, well for exam 1 there's like 1 extra video for the answers to that, and then everything else is on exam 2 and exam 3. If that makes sense.
Nah, that didn't make any sense because I was too busy trying to find the BC page on the College Board thing.
On the YouTube page?
Yeah. So I'm on their YouTube. Oh, there we go. Okay, now it's working. All right, I'm on their YouTube page, and then I gotta find Calc BC, right?
Yeah.
Okay, Calc BC, and then it's
if
the ones at the very bottom, right?
Yeah, and then the answers to the questions given on the video is the video after it, like right after it. At the beginning, before they give out the next test.
Okay, so they've got exam details and timed AP exam, exam details and timed AP exam. I assume, let's see, what is this one called? No, that's best wishes. Nobody cares about their best wishes. There we go. Okay. So there's 3 different videos that say exam details and final and AP exam practice 1, exam details. And so, okay, is at the end of practice exam 1 are the answers, or at the end of,
It's
or
the
at the beginning of,
It's the beginning of the video after practice 1. So
the exam tips one?
Yeah, and then for practice 2 and 3, it's the videos after that too. So for 2, it's on 3, and then 3 is on the video after.
Okay, I gotcha. All right. So is that, I'll send out a message with all of that if that works for everybody, to just take a look at those that way.
Yeah.
And then if you have questions on them, just send them to me through Remind.
Sounds good.
Does that work for everybody?
I have a quick question.
Yeah.
So there is another sample FRQ. It's not really it's part of the College Board website. I think it was 2019 FRQ number 2, part A.
Okay.
Can you explain that one?
Yeah. 2019?
Yeah, number 2, part A.
No, 1 second. I got to pull it up on my phone here. 2019 BC FRQ Part A. Let's see here. BC 2019 number 2 Part A. Ah, shoot, this is just the answers. This isn't well, I'm looking at it at the moment. All I pulled up is the answers, but it looks like that's a polar one. Let me see if I can find the actual questions. Yeah. Number 2 is it's a polar question. You're not gonna have to do any polar.
Mr. Bachelor?
Yeah.
I was wondering, can you go over the 2006 non-calculator free response form B? And it's
Which
like question 5 parts B and C.
Okay. Hold on, Ashvin, are you still there?
Yeah, are you sure that's polar, or are we looking at the same? It's like the one with velocity?
Nope. Maybe it's form B. Because question 2 is
Oh, it's an AB. That's why. So never mind. I was looking at an AB problem. Never mind.
all right. Okay, which one was that? A seam that wanted one? Which one did you want to seam? 2006.
Yeah, 2006 form B.
Form B 2006. Question which one?
5.
Question 5.
And then it was parts B and C.
Parts B and C. Okay, so yeah, so have you read through that sheet that I sent out?
I'm reading through it right now.
That's great. Go to the part about logistic differential equations.
Logistic differential.
Should be somewhere sort of near the end. And what you're given there is a logistic differential equation, and it's asking you what's the limit as x approaches infinity of any of your logistic differential equation. That's what it's asking you for. Part of that. That's the second part of part B. The limit as x approaches infinity of g prime.
Okay.
Right?
Mm-hmm.
Does that make sense? That's the limit as x approaches infinity of your logistic differential equation?
Okay.
Does that make sense, though, that that's what that is?
Yeah.
Okay. That's always equal to 0.
Okay. All right.
Because what it's doing is, this is your logistic differential equation. This is what's happening. What is the rate? This is the logistic equation, the logistic growth model. As we go towards infinity, the rate of change is becoming 0 because it's approaching the horizontal asymptote.
Okay. That makes sense.
The other part of it, it's asking what is the limit as x approaches infinity of the solution to your logistic differential equation. And that's always equal to the carrying capacity, because what's your function doing as you go towards infinity? It's reaching that horizontal asymptote, which is the carrying capacity.
Okay. All right. Yeah, that makes sense.
Okay.
All right. Perfect.
That makes good sense for B. Does that make sense to everybody? Whether or not you're looking at the problem, just the concept there. If you have a logistic differential equation towards infinity, the rate of change, which is the differential equation, is approaching 0 because it's flattening out to that asymptote. And the solution to the differential equation looks like this. And so what are you approaching as you approach infinity? Well, it's the horizontal asymptote, which is always represented by the carrying capacity.
So like, if there's ever a differential equation that like only has like the y variable in it, can I kind of automatically assume that it's going to be like a logistic differentiation thing?
Nope.
Okay.
It's a separable differential equation, and whether it's logistic or exponential growth, it depends on the form of it. And they're both written there. If it's the dy dt is equal to k times y, it's just this, that's exponential. But if it's, we usually use dp dt because logistic growth are usually models like the population of a city or of animals in a forest or whatever.
Okay.
Or that one, it's always, k times t times m minus, or sorry, k times p times m minus p.
Okay, yeah. Thank you. Yes.
So for part C, on that one that you were asking about, let me see, I haven't actually looked at that. It wants to know, when does G have a point of inflection? So you're going to have to take a second derivative and see when the second derivative equals 0 or is undefined. And based on the answers I'm looking at, it's saying that that the only time that happens is at 3/2, which is half the carrying capacity. And you'll know, and I think I put that on the sheet also, that there's always, I think actually maybe all I wrote was that it's increasing most rapidly at half the carrying capacity, but that's always a point of inflection on the logistic graph. And I can add that in there also. I'm not sure if I put that in or not.
Okay, so it's always a point of inflection when it's half the carrying capacity.
Yes, if it is a logistic differential equation, the solution to that logistic differential has a point of inflection at half the carrying capacity. I'll add that in to that sheet and resend it out. I'm going to add in a little thing about inverse derivatives also, or the derivatives of inverse functions, because AB asked me to. So I'll throw it in on your guys' also. So look for one more update to that with the logistic differential equation thing and the inverse function rule also.
Okay, thank you.
Yep.
So I have a quick question. So
Yeah.
when you're doing cross section, like for like if they give you like ask a cross section based off of a curve, and then they say like it's perpendicular to the x, does that mean you do it in terms of x or y?
If it's cross section and it's volume, whichever one it's perpendicular to, you do it in that variable. If it's perpendicular to x, you do it in terms of x. If it's perpendicular to y, you do it in terms of y.
Okay. Okay. Thank you.
Mm-hmm.
Wait, so if you already printed out the review sheet that you gave us on Sunday, but then you came out with a new one, should we reprint it or just keep the old one?
I mean, if you wanted to have all of the information on it, I'd print the new one.
What did you add to it?
I don't remember. When did you print it out? When I first sent it out?
Yeah, like Sunday night.
If it was the first iteration of it, I've added quite a bit to it since then.
Okay.
I added in like a bunch of limits that you should just know. I added in, I don't know. I've added in a couple different things.
Okay.
I would wait until I add these last things and then print it out then.
Okay. Thank you.
Sorry about you wasting paper there. But.
That's all right.
When you're calculating speed, I remember we used to do like velocity times acceleration to figure out if it's like, figure out like the sign. Like you'd create like a sign chart with velocity and acceleration. You'd multiply them together to see if the speed is increasing or decreasing over an interval.
Right. Yeah, so I didn't put that on there either. I should put that on there. Let me make a note of that. Hold on one second here. Okay, so the velocity and acceleration. Yeah, velocity and acceleration have the same sign. then the speed is increasing. And if they have opposite signs, the speed is decreasing. So I'll add that into there. I'll add in the point of inflection, carrying capacity thing. And I'm going to add in the inverse rule for derivatives because AB wanted that. So. Cool. I'll put those 3 things in tonight and send it out. It might not be till late tonight because I gotta go. I have to go sit in my mother-in-law's front yard for her birthday this evening and sit there 6 feet away or something. Any other questions?
What exactly does extreme value theorem prove?
Does what prove? I couldn't hear you.
Extreme value theorem? I don't really
The
get what you
extreme value theorem says that if a function is continuous on a closed interval, there has to be an absolute max and an absolute min on that interval. That's all it's saying. So what we usually use that for is if we're asked for the absolute max or min and it is a closed interval, we have to check the endpoints just as a reminder that it's got to be the endpoints. And the extreme value theorem says it could be at the endpoints or it could be on the interior, but there is always an absolute max and an absolute min for a continuous function on a closed interval.
All right, cool.
Yep. Other questions?
Yeah, I have a question. So if it's a piecewise function and it's like asking to prove continuity, we would set the like 2 piecewise equations equal to each other for that point that it's like not continuous at anymore. But if it's asking to prove differentiability, what would we do?
If it asks you to prove the continuity, just set the functions equal and see if they're the same. If it asks to prove differentiability, first set the functions equal to each other and show that it's continuous there. And then take the derivatives of both sides and set them equal to each other at that x value and show that the derivatives are also the same. So you have to do both. You have to check for the continuity first and then check for the derivatives being the same or equal to the same value at that x value. Does that make sense, Priya?